So today I just discovered some new math. I woke up today and just realized that 1 equals -1, and I'm going to be proving it in this video. I know you might be asking, how do I know that 1 equals -1? Well, the thumbnail says 1 equals -1, so surely it must be true. Why would the thumbnail lie? So here's how we're going to do the totally legit proof. So we start with 1, because it's always nice to start with 1, right? Then we rewrite this as the square root of 1, which also equals the square root of -1 times -1, since 1 equals -1 times -1. So far, so good. The next thing I'd like to do is to apply the property square root of a times square root of b equals square root of ab. This is a basic property introduced when first learning about simplifying radical expressions. So what I'd like to do is to apply this property and do the totally legit step of rewriting square root of -1 times -1 as square root of -1 times square root of -1. This is totally going to work. Just trust me, bro. Square root of -1, as you know, is the imaginary number I, so we can rewrite this as I times I. And I times I is just I squared, which equals -1. So we started with 1 and ended up with -1. This means 1 equals -1. It looks like we just broke all of math with this new discovery, and everything we've known is probably not real. Yeah, so obviously I'm kidding. 1 does not equal -1. That doesn't even make sense. And of course, there's something wrong with this proof, which is kind of the point of this video. Whenever you get a contradiction like 1 equals -1, it means you made a false assumption, or you just did something wrong. So let's go back to the proof to see what went wrong. So we started with 1, and we wrote that as the square root of 1. So far, so good. We then said that's equivalent to the square root of -1 times -1. Is that correct? Okay, yeah, I'm just kidding. This part is actually fine. We're just rewriting the 1 inside the square root as -1 times -1. But it's really the next step that causes issues. I made the claim that the square root of -1 times -1 equals the square root of -1 times the square root of -1. And this is really the unjustified step. I was using the property that square root of a times square root of b equals square root of ab, which actually has the nuance that it only applies if a and b are not both negative. It works if a and b are both positive, which is probably the form you're most familiar with, but it also works if at least one of a and b are positive, and the other one is negative. Where it breaks down is when a and b are both negative, which is what we have in this case. The actual extended property to include negative numbers is square root of a times square root of b equals square root of ab if either a or b are greater than or equal to 0, which basically means if a and b are not both negative. If a and b are both negative, then square root of a times square root of b equals negative square root of ab. So with this new knowledge, we can fix our proof so we don't get something nonsensical like 1 equals -1. So instead of saying that the square root of -1 times -1 equals the square root of -1 times the square root of -1, we should instead correctly use the property and conclude that it equals negative square root of -1 times square root of -1. I'm just applying the case where both a and b are negative and moving the negative sign to the other side of the formula. So instead of square root of a times square root of b equals negative square root of ab, we have square root of ab equals negative square root of a times square root of b. If we continue this, then this is equivalent to negative I times I, since square root of -1 is I, and this just equals negative I squared, which equals -1, since I squared equals -1, and this simplifies to 1, so 1 equals 1. Yes, we just proved that 1 equals 1, so we weren't quite able to prove that 1 equals -1, but at least we were able to prove that 1 equals 1. What do you think? Can I consider this a win? Tell me in the comments if this is a win. So here's an intuitive way to understand why this proof failed when applying the unjustified step, and also why you need that extra negative sign in the formula square root of a times square root of b equals negative square root of ab when a and b are both negative. What we really need to do is to look at what's happening in terms of signs. So let's assume that square root of a times square root of b equals square root of ab, even if both a and b are negative, which as we have shown is false. If we start with a positive real number, that's the square root of a positive number. We can rewrite this as the square root of a negative number times a negative number, and when we try to split the square root by assuming square root of a times square root of b equals square root of ab, even when both a and b are negative, we end up with the square root of a negative times the square root of a negative. If we multiply them back together, you end up with a negative real number because we now have two imaginary numbers being multiplied with each other, which always ends up as a negative real number. So we started off with a positive number and ended with a negative number, which is a problem. If we start with a positive value, we need to end with a positive value. That's why there's an additional negative sign in the formula, square root of a equals square root of b equals negative square root of ab, when a and b are both negative, to ensure that everything checks out in the end. So anyways, we need to remember that square root of a times square root of b equals negative square root of ab when a and b are both negative, so we don't get something nonsensical like 1 equals negative 1.